How does the use of Go Formative in a lesson affect the math students' self-efficacy and their actual performance? I'm Jennifer Rodriguez. I teach high school math, and my teaching philosophy is centralizing the idea that the purpose of education is to engage students in creative, higher order thinking while investigating and coming to their own conclusions, which gives meaning to their learning. So some background information on my teacher inquiry. Being in the field of mathematics education, the majority of my students have fixed mindsets about the subject. The issue led to my inquiry was that fixed mindsets are reflected in students' self-efficacy and, as a result, their performance in my class. Since we are a one-to-one school district, I wanted to see if I could take advantage of the use of the Chromebook as a resource in improving student self-efficacy and mathematical performance. According to research by Shirley and Irving 2015, the connected classroom technology facilitates more student responses, which can be displayed and interpreted as they are submitted, which this provides more immediate feedback both for the teacher and the student. I hope that by receiving immediate feedback when they began to practice new math skills, that students would feel more confident when completing entrance or exit tickets. Student confidence should improve performance, which will continue to increase their confidence and their performance. The purpose of my study was to boost students' self-efficacy and performance through the integration of specifically Go Formative, which is a digital formative assessment tool that allows me to provide one-to-one feedback to all students straight from my computer to theirs. I could see all the student responses all at once as they were working, no need for submission. The advantage of this is that I can reach more students that are having the same mistake. I could very quickly point out and provide that feedback. This relates to my wondering about how using Go Formative in a lesson affects the math students' self-efficacy and their actual performance. So, how I planned on collecting data was that students typically complete exit tickets or entrance tickets after traditional guided practice approach, where the lesson was offline, and so was the guided practice. And afterwards, either at the end of the period or at the beginning of the next day, the students would submit their exit tickets into either a red, yellow, or green bin. The red meaning, I found this tough, I need help. Yellow means I understand some or most of it, but still need some practice. And green is I understood, I'm ready to move on, I can help others. Then afterwards, students completed exit tickets with guided practice completed on Go Formative. And then these were submitted to the same traffic light bin. So the exit tickets were on paper in both the before and after. And so how I analyzed the data, I took the percentage of each of the solving equations entrance tickets or exit tickets that were placed in the red bins, as well as the percentage in the yellow and green bins. And then the same was done for the inequality entrance tickets. So the equation exit tickets, solving for equations, that was with the traditional approach. All guided practice was on paper, offline. And for the inequality entrance and exit tickets, we did our guided practice on Go Formative. I decided to stick only to those specific topics as the math skills were very similar. The skill needed was very similar. So I wanted a little bit of a control and avoid any other any other feelings towards specific skills. So I wanted the same kind of feeling, so for the two skills being compared. These percentages help check improvement in self-efficacy within each of the methods of instruction. So I kind of wanted to see if how the self-efficacy improved over the solving equations from one topic to the next in solving equations, and then do the same for the inequalities. Then I also took the average percentage of the three equations exit or entrance tickets on the green, along with the average on the yellow and average on the red. And the same was done for the inequality exit and entrance tickets. And these help compare percentages in the red for the equations versus the red in the inequalities, and the same for the percentages in yellow and percentages in green. And lastly, the average percentage of actual performance for equations versus inequalities was determined to see if to compare the improvement versus the their self-efficacy level. So results. Sorry. The use of Go Formative improves student self-efficacy from one inequality topic to the next, as measured by the percentage or exit of exit or entrance tickets placed in the traffic light color bins. Although going from traditional to using Go Formative did not demonstrate much change in the green or the higher level of self-efficacy, it did show improvement in self-efficacy for the lower yellow and red levels, which is good because those are the targeted groups, the students who are not feeling as comfortable or as good with their performance or abilities. In both the traditional and Go Formative approaches, green level and red level self-efficacy demonstrated to be higher than the actual performance. However, actual performance was higher than the yellow bin self-efficacy placement of exit or entrance tickets. And I think it has to do with the fact that I've been addressing growth mindsets in my class since the beginning of the school year, so that's why their self-efficacy is a little bit higher than their performance. But I was glad that those in the yellow who were placing themselves in the yellow were actually doing higher, so that should help my students see like, oh, I'm putting in the yellow, but really I'm doing much better than that. And so implications or concluding thoughts based on the results of this study, the idea of celebrating improvement rather than high grades when moving from fixed to growth mindset is reinforced. This is due to the improvement of self-efficacy in the lower levels and improved performance in the yellow level. When performing the study, I introduced Go Formative to my students in a warm-up to get them used to the use of Go Formative and see what their preferences were for using handwritten option or the typing option or a combination of both. Students were still trying to get used to the program when I ran the study, and this can affect the result of the study since I did notice some frustration in a couple of students, and this frustration does improve with exposure to the program. So I was trying to keep the study for a specific content with similar skills for comparison, but I think a longer study might show greater self-efficacy improvement as the frustration in the program decreases. And next steps with my research on the impact of digital tools and self-efficacy, many more classrooms can benefit, hence I will become an agent of change by first sharing my findings with my department and also through the Unit of Study Power School page so that the rest of our district math teachers have access to the information. Thank you.